Video for the exam 2 solution. This was problem 1 where we had 2 crates, and you have your problems, you have the values that you had, and I am going to use my own values. Let's see here. Okay, so here was problem 1. So we start out with a free body diagram and an inertial body diagram, and because this thing is on a curve, right, there is actually going to be an acceleration downwards. So this is block A. This is mass times acceleration of A, and this is in the normal direction here. And let's see, in the forces, okay, so there's also, it's going to be accelerating this direction too. And we'll call this the A in the tangential direction, and we'll say that that's tangential and that's normal for this. And so we're going to have the weight of A, and we'll have the friction force of A and the normal force of A. There'll be the tension here. Let's see, did I forget anybody? I think that's it. Okay, and let's see. Okay, some of the values that I'm going to use for this. Let me see. I had them written down somewhere. I'm going to use that WA is going to be equal to 20 pounds. WB is equal to 50 pounds. The velocity of B, which is also the velocity of A, I decided not to make this thing a pulley here, is 10 feet per second. That's what I had. And I had the coefficient of friction was going to be 0.2. And I had the radius of the hill was 20 feet. Do I have anything else? I think everything else is stuff we can figure out. Okay, so do the sum of the forces in the normal direction, and we'll say that downwards is positive, just to try to reinforce the sign convention that we have in there. It's mass times acceleration in the normal direction, and so we're going to have the weight is going to be that direction, but it's going to be subtracting out the normal. I meant to go Fn. A right here, and anybody else? Nope. Okay, and then it's going to be equal to the mass of A times the acceleration of A in the normal direction, which is v squared over r. So we end up finding in the normal direction. So we're going to flip this guy back over to the side, and I just want to double check something. Am I got everybody in there right? I guess I do. Okay. So this would actually be WA minus MA over V squared over R. So for my values, I have 20 minus 20 over 32.2, and the velocity is 10. And we have 20 right here. So let me think for this. 20 and 20 and 32.2 divide times 100 divided by 20, and I get 3.106, and subtract that from 20, and I get 16.89. Just want to double check. Yeah, 16.89 pounds. And then if I want to get the friction of A, we take mu times F and A, and I get 0.2 times my 16.894. And so that's 3.379 pounds. Okay. And then I have the sum of the forces in the tangential direction, mass times acceleration in the tangential direction. And so looking back up at here, we see that we're going to have a negative friction, but a positive Ft, and I think that's the only thing else we have in there. There's going to be mass times acceleration in the tangential direction. And we could even just say that that's just going to be the acceleration. Well, I guess it is, but it's actually equal to the acceleration of b, right? So in the tangential direction, this is equal to the acceleration of b. So we could write that. So I'm going to write out my this equation right here by my friction force A plus ma times acceleration of b, right? Because they're connected by a cable. So we have 3.379 plus my 20 divided by 32.2 times AB. Maybe I could go ahead and turn that into a number, or I could just call this my equation 1. Come back to it. Now I go to my other piece right here. We need a separate free body diagram for it. Separate free body diagram and inertial body diagram. Let's see, I started to draw it over there. Let's move that down just a little bit. So we got a weight of B. We have a tension force coming up this direction. We got our normal force of B coming that direction. It's going to, friction force is up in this direction of B, right? Because it's going to be moving down there. And then we have the mass of B times the acceleration of B. And did I forget anybody? I think I got everything. I think the only thing I'd want to know is that they're going to be that angle theta. So I could say the sum, and then I like to call this x prime and y prime. So the sum of the forces in the, let's start out with the y prime direction, mass times acceleration in the y prime direction. That's positive, but that's going to be 0 in this case. So let's see. I'm going to have a negative weight of B times the cosine of theta. And oh, I assigned theta as something up here too. I forgot to write up. My theta was just 60 degrees right there, yeah. So I forgot to put that in there. And moving on here, that's that direction, and then plus FNB, and it's going to be equal to MBAB right here. So FNB, which is what I'm trying to solve, I'll go ahead and put numbers in for here. So this was 50 pounds this time, times the cosine of 60, and we see that it's going to be plus, yeah, and then 50 over 32.2, and then B. Nope, I just messed up. That's supposed to be equal to 0, dummy. My brain wasn't in it. I don't know what I was thinking. All right, boom. So I think that's all we have in that direction. I hope so. So 50 times the cosine of 60, which is done in our heads. All right, 25. So the friction force of B is just going to be mu FNB, or 0.2 times 25, which is 5 pounds, right? 5 pounds. And now we do the sum of the forces in the x prime, mass times acceleration in the x prime. So we're going to have negative Ft yes, minus FFB, right? And then plus WB times the sine of theta is equal to MBAB. So I said I've decided to solve for, this is the equation that we have up here. I decided to solve for ft right here. So and then I put him. I guess I brought him over to this side, and then I brought him out here. So what we essentially have is WB sine of theta. I'm going to get the signs messed up here if I'm not careful, all right? Minus FFB right here, and then but minus MBAB, I think. And sine of 60 minus 5 minus 50 over 32.2 and an AB. Yes, okay. So let me get rid of some of that. 60 sine times, but then we're going to subtract out 5, and we end up with a 38.30 minus our 50 over 32.2 AB. So that's our second equation. So we can set equation 1 and equation 2. We can just set them equal to each other. And so I have 3.379 plus 20 over 32.2 is going to be equal to 38.3 minus 50 over 32.2 AB. Whoop, I forgot my AB here. I could find that the acceleration. Now I could have done it the other way right there. I could just solve directly for the FT. But I like to find out what the acceleration was going to be. And so I didn't ask you for the acceleration. I asked you for the tension. But what we're going to do is this is going to get subtracted out from there. So 3.379 subtracted out. And then you notice with the 50 and the, so I'm actually going to have 70 and 32.2 and divide, and then I'm going to divide out, and I find out that I have 16.06. So it's like 1/2 of gravity. Like it's half, pretty close, right? But then we're going to find out that the tension right here, we could put that back into either one of these equations. I guess I'll stick it back into this one. And so 50 times 32.2 divide. We're going to subtract. Ooh, I don't know if I like that. Feeling kind of bad about it. No, I think I got it right. Yep, okay. 13.36 pounds is what my values would be doing this, but you can look up and see what your values are. I think I'm going to separate these into different videos in case something comes up. So let's see. It's not letting me click on this. Why aren't you letting me click on it?